So, hello everyone. Today, what we're doing is a lab on the inverse square law. So let me just remind you what we know about the inverse square law from lecture. First thing is, it applies in a specific case, that is when we have an isotropic source of waves. So remember, isotropic means the source radiates these waves evenly in all directions. So a good example of an isotropic source would be something like a light bulb, or better yet, the sun. In each of these cases, the waves are spread out evenly in all directions. There's no preferred direction where the light is going. On the other hand, if you think of something like a laser beam, that's very anisotropic, meaning all of the energy is basically going in one direction and none of it is going anywhere else. So we're talking, in this case, about isotropic sources that radiate evenly in all directions. Okay, so as long as you have an isotropic source, we expect that it follows the inverse square law. And the inverse square law is basically a really simple relationship between the intensity of the wave and the distance from the source of the wave. The inverse square law says intensity falls off with distance according to the distance squared. So in other words, intensity is inversely proportional to the distance squared. That's what we expect to happen for an isotropic source. So today we're going to put that that idea to the test for an isotropic source of light, which is an LED light source, and we're going to measure the intensity using a light sensor. So what we're doing is very simple. We're simply just moving the light source further and further away from the light sensor, which measures the intensity, and we're seeing how the intensity changes with distance. Okay, does it follow the inverse square law? How closely? That's what we're going to investigate today. All right, so this is our experimental setup right here. On the track, we have two pieces of equipment. On the right-hand side, this is our light source. This is actually an LED light source, and it can move along the track like this to any position we want. On the left side of the track, we have our light sensor. We're going to actually keep the light sensor fixed. We're just going to leave it at the left end of the track and not move it throughout the experiment. But what the light sensor does is it tells us the intensity of the light that it's picking up. So we can actually read out the data on our computer interface like this. So here's more or less how the experiment will go. We're going to put the source, which is on the right, and the detector some known distance away. We can measure that using the track here. And then we're going to measure the intensity. We're going to move the source back a little bit, increase the distance, then measure the intensity again, and then move it back some more, and then measure the intensity again. If we do this many, many times, we can get a pretty good sense of how the intensity depends on distance, which is the goal of the experiment. So I've cut the lights off in this room. But as you can see, there still is light coming in through the door here. There's plenty of light coming from my monitor. And what we call these sources of light are background sources. Ideally, my sensor is only picking up the light from our LED source here. We don't want it to be picking up light from our background sources. That's only going to confuse our measurements. So we want some way of subtracting off the background sources. And what I'm going to do is show you how that works. So if we go over to the computer monitor, we see that the intensity that's being read out is not in any sort of physical unit. It's given as a percentage. So 73% means it's at 73% of the maximum intensity that it can read. Now let's go over and switch off the LED light source. And then back to the computer. We'll see the intensity reading has decreased. Now it's only at about 13.6%, but it's not at 0. And that's a problem because our light source is off. It's only picking up, that 13.6% is only from the background sources. If we want to eliminate those background sources, we have to subtract off that 13.6%. And the way we do that is by zeroing out our sensor. Okay, so just hit this button here to zero out the light sensor. And now the intensity is reading 0. which is exactly what we want. We want it to be 0 intensity when our light source is off. Okay? Now I turn the light source back on. And if we go back to our intensity measurements, now we're at about 59 or so percent. And if I turn the light source off again, it goes back to 0. So in that sense, we've eliminated the background light. Okay, by subtracting off the background or by zeroing off our sensor, we've eliminated the background light. So we'll keep doing that throughout the experiment. Okay, another thing you have to be aware of as it pertains to the setup here is something called saturation. Okay, so the sensor, the light sensor we have, it can read light intensities out. It can measure light intensities, but only up until a certain point. So let me show you what I mean by this. Of course, if I push the source closer and closer to the sensor, the intensity is going to get bigger and bigger because, of course, the closer you are to the source of the light, the more intense it is. But if we look at, on the computer, what happens to our intensity readings, okay, I'm going to pull the light source back a little bit. So you see it's around 67% intensity. And now I'm going to slowly push the light source towards the sensor. You see the intensity is going up, as you'd expect. But now look what happened. The intensity is basically stuck at 85%. Even though I'm pushing the source closer and closer, even though it is getting more intense, our sensor has become saturated. It's not able to measure that increase in intensity. So the lesson here is, if you push the light source too close to the detector will become saturated, and basically your data at that point is garbage. So we want to avoid saturation. So here's what I'm going to do. I'm going to start with the light source really, really close to the sensor like this. And then I'm going to slowly pull it back. And while I'm doing that, I'm just going to show you what we're reading from the sensor on the screen. Okay, so I'm now pulling back the source. And you see the intensity is not really changing. Still pulling it back, still not changing, so we're still saturated. Okay, now it's starting to go down. Okay, so where did that start happening? Well, if I read off the distance on the track, it's at about 14 centimeters. So, in other words, if my source is 14 centimeters away from the detector, then it becomes saturated. Again, I don't want that to happen, so that means I want to stay away from this range here, where the detector becomes saturated. I want to stay back over here in order to not saturate the detector. So 14 centimeters is what we call our saturation distance, and we're going to make sure we don't get within 14 centimeters of the sensor to avoid saturation. So we're now ready to actually take our first measurement. I've moved the light source back away from the sensor, so now it's at 19 centimeters separation. So again, we're avoiding saturation by doing this. And so let's take a measurement of our intensity. So at 19 centimeters between the source and the detector, our intensity is 48.72%. So 48.72. Okay, next, I've moved the light source back 5 more centimeters. So now we're at 24 centimeters of separation. And if we look at the light intensity we're measuring, it's 32.16%. So 32.16. All right, so the remainder of the experiment goes in pretty much the same way. We're going to have a total of 10 trials. Each time we do a trial, we move the light source back by 5 centimeters. So in doing so, we're decreasing the intensity. That's something that's going to be reflected in the data. And for each trial, we just simply measure the distance between the source and the light sensor, and we measure the corresponding intensity. I'm not going to show you all of those measurements in this video. I'm just going to give you the numbers up on the screen at the end of the video. And that's it for the experiment. So when you go home and do your analysis, what you're basically going to be looking at is to what extent does the data we collected here actually agree with the inverse square law. So that's something you're going to look into in the analysis. Okay, so follow the handout that I gave you to accompany this video to show you how to do the analysis. And with that said, I'll see you in the next video. Until then, be safe and be healthy out there. Take care.